Hello, everyone. Welcome. I hope you have had a great gRPCconf or gRPConf. I don't know. They switch it every year uh, so far. And this is probably the last talk before you can enjoy. So I hate to be the person between you and your happy hour. So I'll keep it short. So this talk is about fortifying gRPC microservices, how to secure your microservices. I'm Mehrdad. I work at Signeen. At Signeen, we work on security solutions. Specifically, we have a authentication server, which is API compatible with Auth0 that you can replace with and just deploy it on-prem as well as on cloud. And we are also having solutions that help you deploy microservices securely in your infrastructure. And I've been on gRPC team a number of years ago. I've been at Dropbox deploying gRPC, and these are some of the experiences that we had deploying like secure gRPC microservices. So let's get started. So why do you even want to secure your service-to-service communications, right? You can just use TLS from the client to your edge and terminate the TLS there, and then establish an insecure connection from your edge proxy to the backend server, and then all the internal communications would be unencrypted plain text, but it's within your firewall. So it's probably not an issue. So what can possibly go wrong? I don't know if we have Gen Z audience here for me to explain this, but this is basically one of the slides that were leaked out of the Snowden revelations more than 10 years ago now. So the key piece is the SSL added and removed here. So basically, at least one of the things that can go bad is you have a nation state looking at your internal communications that are going in plain text. But you'd probably still ask, my threat model is not that. Like, why do I care? I'm probably OK with that. So there are a number of things that this still helps you with, right? You can, if you have multiple cloud, as we saw in the keynote, this is also a very common situation where you have multiple clouds and you want to establish secure communication across clouds. So then you need some sort of security there. If you have external APIs, that's essentially a different, a special case of multi-cloud scenario. Right. The other thing is it's actually very hard to configure your security boundaries if you rely on security boundaries, right? It's much easier to say, basically, we do like zero trust, as they say, and we define our policies, which service can access what service, and enforce it at the service-to-service communication layer. And it would minimize the risk of something going wrong if just the firewall rule is misconfigured and like someone basically like directly sends an RPC to some sensitive backend, and you cannot do anything about it. And there are also some non-security benefits that may be neglected. For example, at my previous company, one of the things that we benefited from is we had a service discovery infrastructure that was very quick to update whenever like a backend server went up or down. So on the same IP address, you might be hosting multiple services at different times. And if for any reason your like local cache is not up to date, you might end up sending an RPC to a different server than what you intended, and get some like undesirable states, right? You don't want to be there. So those are. So one thing that we can do is API keys, right? Like issue API keys to each client for a connection to each service. So when you think about this, you can do it in a number of different ways. You can do it like in an NS² fashion, where each client for each server has an API key. And good luck managing that, by the way. I'm pretty sure if you do this stuff, one of the things that you're going to see in the wild is that you're going to even have like timing attacks on your API key validation logic. So I've seen this a number of times where essentially like two strings are being compared, and an attacker can just try to use timing attacks to find your key. So those are like just implementation issues that you're going to have. But in terms of like assuming your code is correct, you're going to have a huge operational challenge. So you're probably going to go with, oh, what if we give each client essentially a key, and that would be the identity and like the credentials of that client. Then the problem is like that key can be stolen. And also, if your communication is not encrypted, that key can be passively, a passive attacker looking at a network stream can just take that and do a number of things. So you do want to encrypt, right? So actually, before encryption, there's another solution that helps you with just a key management problem, right? So you can have an auth service that issues access tokens that are temporary. So they're valid for a certain amount of time, and then use that token with gRPC as a basic authentication in the HTTP header, right? So that will work. But still, if you are not encrypting the stream, that token can be taken out from the network stream. So even if you do that, you need some sort of encryption, right? So we solve the token leakage problem because they're pretty short-lived to some degree, but they can still be stolen. And there's still this open issue: how do we authenticate ourselves to the authentication service, which we'll address in the future. But this is still a problem in this scenario, right? But we do want to encrypt the communication. So the obvious choice is TLS, right? We're using TLS all the time for connecting to any HTTP server on the internet, these days at least. So why not just use mTLS with gRPC? It works great. Issue certificates and private keys to each service, and they can, you create a secure credentials in your code, pass the TLS certificate and private key, and then you just connect to the service that you want. And the service that you're connecting to can also authenticate you with mTLS, right? So that's easy. So let's dig a little bit deeper into this. What is really a certificate? A certificate is a name, is a public key, and a cryptographic signature that binds the name to that public key, so that when the other side sees this communication is from you and from a certain public key, it can also validate that this public key belongs to you. And who is you, really, is the question that you're addressing today. So what I call traditional mTLS, which I just described, has a number of issues in the gRPC context. In the browser context, there is this agreed upon way to authenticate the server, right? When you say like google.com in your domain name, it basically compares whatever is in that certificate to the google.com that you're reaching out to. And if it matches, then the certificate is good. If it doesn't, it says, oh, the connection is insecure or whatever. You're not supposed to connect to that. Plus, there is a known set of certificate authorities that you rely on that are predefined, right? When you're building your own gRPC infrastructure, first, you probably don't want to rely on the public trust PKI. You want to have your own internal certificate authority. So you need to manage the trust, the root of trust, right, in that environment. The other bigger issue, actually, is that like the name, the domain name or the IP address in the certificate is not a good way to validate who you're talking to. Right? This is actually a big problem because, again, like in a cloud native situation, like services are spawn up on different IP addresses each time, right? So you don't want to use that to anchor your name. So in practice, what we did at one of these large infrastructures was we disabled gRPC. We told gRPC not to validate the name. It still validated the public key and did the authentication. And then we had a function that whenever a connection was established, according to our rules, look at the certificate and see if we want to communicate with that endpoint, right? So this is actually brittle and dangerous code, right? And this was a number of years ago that we had to do something like this. So those are some of the issues with mTLS in the traditional sense, right? And even with those issues, that's actually quite practical. Like you basically have a daemon that distributes certificates to nodes. Like in our case, we put it in a directory, and like with access control of the OS, you can actually tell your process to be able to read the certificates that are supposed to read. This was not necessarily like a cloud infrastructure. It was an on-prem system that I'm talking about. So we didn't have fancier tools. So we had to rely on Unix permissions, essentially, to get this done. And then we had our own validation function, as I described, and we disabled it. The way we did the refresh of the certificates was we essentially issued 1 month certificates with 1 month of validity, but we renewed it every 2 weeks because you don't want to do it at the same time. It would that would actually be a SEV if you try to issue certificates at the same with the same validity as your expiration. So, but there's another thing that's that I should note here is that it was at the time a little bit difficult to reload certificates within gRPC. I think now, at least if you have access to gRPC core API, you can do this. I don't know if all languages expose this, but that is a concern. But we did actually patch gRPC core at the time to do this. So given that problem statement that I just described, smart people also had these issues. Like you can imagine a lot of people have these issues. And they essentially standardized on this spec called SPIFFE. Part of this spec, what it tries to accomplish essentially is to standardize that naming and attaching it to the certificate, just like the browser TLS system is a spec, and it says, oh, this is how you're supposed to validate it. And with SPIFFE, you have essentially a SPIFFE ID. It's called SVIT. That is, it looks like a URL. It's a URI, and the URI consists of a trust domain, which essentially is the PKI root, the certificate authority in this case, that issues certificates for your infrastructure. And then there's a path, right? Usually this could be a server name, depending on how you want to organize your services, that's like flexible. But it's important to see that the trust domain is also explicit in that name. And the benefit of that is you can have multiple trust domains in a multi-cloud scenario or like multi-organization scenario where each organization has a bunch of microservices and these guys want to communicate with each other. That can help you do that because SPIFFE is designed essentially to address multiple trust domains with multiple services. So how do we bring this all together here? So as I mentioned, SPIFFE is the specification, right? There is this project called SPIRE, which is a CNCF project, that's essentially the building block in the implementations and actual code that you can run. And it has multiple components in it. SPIRE is essentially like the realization of SPIFFE in a production setting, right? And both gRPC and Envoy can utilize the SPIFFE credentials, right, to establish like mTLS. The actual mTLS is no different than like the regular one. The protocol is the same. It's just the validation, how you get the public key, how do you distribute the certificates. It's different, right? So this is how it's going to look like. As I mentioned, SPIRE has various components. I'm actually simplifying here. So in this diagram, you can see service A talks to the SPIRE agent that's on the same node. That SPIRE agent essentially validates that service A is who they say they are, right? Because how do I know, right? The way they usually know in a cloud scenario is that because a container orchestrator has some like metadata and some like magic access to things, like for example, if you run things in a Google Cloud environment, you have some secrets that come from the host to your container, right? So that's how you essentially attest this workload. and say, oh, I know who you are, so here's your private key, essentially. And this happens at runtime. So you don't have to manually provision this stuff. So that way, your service, your gRPC process, essentially gets access to the secrets that it needs to establish the communication, right? And then SPIRE server really is the manager of all these trust bundles and certificates and the policies that who should essentially get this certificate data. The workload API is the API that you use within your gRPC process. That's what you have to call to get your credentials. So you do have to interact with the workload API. The SPIRE agent exists. You can just run it, or your cloud environment will run it for you. And you use the workload API to get credentials and simply use that credentials to talk to the service B. Yeah, I'll have time. Right, we'll do that. It's almost done, and we can talk about this. So essentially, all of this magic is done by SPIRE, but also it's important to understand it's a little bit harder to run this on-prem because you need to supplement the SPIRE agent with that attestation, as we call it, to bootstrap these keys, right? So these are like easy to run in a cloud environment, but a little bit harder if you want to do it on your own. Nevertheless, the SPIRE agent is open source, and you can just take that and do things like this. In any case, from a gRPC standpoint, you just talk to the workload API, you get your credentials, and you invoke an RPC. You don't have to manage anything. You don't have to worry about anything, really. This is as if you're using an AWS service within AWS, and you say, oh, this is the security policy, and I'm just calling S3 on that object, like put on that object, for example. As easy as that. And you can have this for all gRPC services, which is pretty magical if you think about it. So that's essentially all I had to talk about, and I'm happy to take questions at this point. Actually, she was first. So. I'm going to go back to the slide. Yeah, go ahead. So, actually, I think you need a mic.
Yep.
So there are multiple questions about this framework. One, in this picture, if I understand that correctly, SPIRE agent is the one generating the certificate, which is the identity. Unless well, at least based on the protocol, it looks like the agent. So now, I guess what that means is that the agent must have the authority, is the PKI engineering, and is able to issue the certificate. For Kubernetes, probably that's easier with the control plane, and they have their own authority, right? In our scenario, it's not that easy because we centralize that function. So this becomes a really challenge. That's one. And two, I think the attestation includes nodes level attestation and then also workload level attestation. And in the cloud, as you said, it's easier because it's under control. On-prem is hard to predict because sometimes you got a VM, you got a bare metal servers, and doing node level control, it's not as easy as you would think. Is that something that you also encountered in the past?
Yes, I absolutely agree with you. So these are, let me answer your question in a different way. It's absolutely true that these are like painless to do in the cloud setting, and even like on Kubernetes, it's probably okay. And for the audience, yes, there are two attestations here. One is that the agent itself has to prove to SPIRE server who they are, and then like the workload has to prove to the agent who they are, right?
Yes.
So there are two levels of attestation, and I would say realistically, if you want to build this on-prem, the harder part is for host for the node attestation, because like when something is coming up, like there's no security material, like key material there. So I would say in an on-prem scenario, you would probably need to do some manual daemon, have some manual daemon per node to get some certificates or some key material that then you can use to prove to the SPIRE server. That said, if you look at it from a different angle, it's still so much better than if you didn't have this stuff, right? Even if you have a not so secure attestation methodology, you're probably much better off than not securing this system. So you basically like reduce your security at the attestation moment, but still like the rest of your system is much more secure. And also maybe there will be ways for you to have like in the future improve upon that.
I totally agree. That's why we're on the same journey
Yeah.
as you just mentioned. Okay, it's been a while, but the other thing I want to ask, I promise is the last one. The when we have SPIFFE credentials, at that point when you verify that, what do you actually normally verify as SPIFFE? Besides, this is a there's a SAN field. You have SPIFFE identifier in there, which tied to my policies, but at the same time, are you kind of look up the certificate details to verify each of the things that's listed there, or what specific things that you verify as a authentication, a way of authentication?
Right. I think that's a great question. I think what I talked about was mostly an authentication, solving an authentication problem. I think what you're asking now is more like an authorization question, right? How do you actually, you know who you're talking to, but do you want them to talk to you? Like that's a different question to some degree. I think both of those are possible. In practice, at least one of the situations that I encountered was where you basically have static policies that are, it wasn't like quite static, but you push the policies in a Zookeeper-based system, and that's a completely different infrastructure than what I described. And the service B in this case will essentially look at their policies and say, oh, yes, I want you to access, like service A should be able to access me. But from the SPIFFE standpoint, they just look at the name in that case.
Okay.
Yeah.
We have a different policy management, so we have that under control. It's just that authentication itself, I'm curious to know, what do you normally do when you get the SPIFFE? What exactly you verify? Not just the mutual TLS, right? Beyond that, what else that you...
So another thing I've seen, I don't necessarily recommend this, is people do this stuff and they still have some like JWT attached to it to get like some additional authorization,
whatever.
But that's definitely not ideal,
that's not
right?
what I'm looking for.
I think in practice you have a different. What I've seen is that the authorization is actually in a much better shape in companies. Like there is some system to look up policies and enforce them, and there are multiple solutions for that. But the authentication piece is actually the harder part, and it's like shameless plug. That's also some of the things that we are going to solve for non-cloud or like mixed scenarios where they need some attestation solutions and things like that. And that's definitely something that's worth looking at. But yeah, we can also talk offline.
Thank you.
Thanks for the question.
So the question I had is, so if your architecture looks like your first sort of yellow background slide, where you have a bunch of like mobile clients or clients that are not necessarily under your control, and you can't install a SPIRE agent on them, how do you bridge this sort of mTLS security out to those clients, or is the answer you cut it off at the proxy edge?
So ideally, if the client runs gRPC or Envoy, you don't necessarily have the SPIRE agent. But in the mobile client scenario, you are probably at some point authenticating to some server and getting, like even in traditional REST APIs, you're getting an access token, right? I would say in that case, instead of the SPIRE agent or anything like that, you basically use that interaction with the authentication server. Instead of giving them an access token, give them either give them the private key, or that's not ideal, or have them submit like a certificate signing request, and you sign their certificate, and now they have a private key, right? So they can directly communicate to your backend server and not terminate the SSL at the proxy layer. And I think that's actually super ideal. Terminating gRPC at the edge for such situation will mean that realistically you'll have from then on, you don't see the client talking to you, you see the edge talking to you. And then you need to have some metadata. Oh, the actual user was this user ID, not edge ID, right? But I've seen situations where people definitely want to terminate TLS at the edge for other reasons, or because they don't have gRPC on the client. They have REST on the client, and then they have an API gateway that does this on their behalf. So it gets complicated, but if your client is able to run gRPC or Envoy, and you don't have the requirement to terminate SSL at edge, then I would definitely recommend giving them a private key somehow, like either issue it or sign. They create it, and you sign it during the initial authentication step.
Thank you.
Thank you.
More questions?
Absolutely. So thank you all for coming to gRPConf and being gRPC users. As a maintainer, old maintainer, I would say. It's great to see all of you at this point. Thank you all, and have a great rest of your day.